I'm Anil Kumar, and now let us summarize our learning about continuous and discontinuous functions. Here we have set of 6 questions. I'd like you to determine whether the functions are continuous at x equals to 2 or not. So we are not saying whether the function is continuous or not. We are only we are only interested in finding out whether at x equals to 2 these functions are continuous or not, correct? So you can pause the video, answer this question, and then look into my suggestion. Now it's a line, so it is always continuous, so I'll write check mark for continuous. This is kind of tricky, right? So we'll think about it. And this is not continuous at x equals to 2, because if I write 2 here, then 2 squared is 4, and 4 minus 4 is 0. So clearly at 0, we have 0 in the denominator, right? At x equals to 2, we have 0 in the denominator, and that makes this function as undefined at x equals to 2, right? So it is not continuous here. This one is an absolute function. They are always continuous. Square root function is continuous after x greater than 0, and we are talking about 2, so that is also continuous. Y equals to 0. What does that mean, right? So these are the questions which sometimes students get confused with. Now let's look into these questions once again. I know you must have got the answer by now. Now here at 2, if I write 2, what do I get? I get 1 over 2 minus 4, and that is fine. 1 over 2 minus 4 is minus half. So this one is continuous. This one is continuous. Do you see that? So it is not x minus 2, it is x minus 2 square. Nor have I written, it is not y over x minus 2 whole square. Do you understand? This function is not continuous. So this is not continuous, right? Because if I write 2 here, we get 0 in the denominator. You get the idea, right? So, but this one is continuous, okay? Now here this function is not continuous. Now the question for you is that what type of discontinuity do we have here? What type of discontinuity do we have? Okay, so that is kind of interesting. To find that, what we can do is we can write this as x minus 2 over x minus 2 times x plus 2. Now since they cancel out, that means we have a whole at x equals to 2, right? So that is what it is. So, and we know these functions are continuous. Now with y equals to 0, what do that mean? Y equals to 0 really means that can you draw this function? Y equals 0 means it is a function which is 0 always. Do you understand? So the x-axis, so we are talking about x-axis here. So many students really get confused. They may put a point here and they may get lost. What happens at x equals to 2, right? Now, so this is a function and it is always continuous. It is the x-axis. Do you get the idea, right? So that's an extremely important question, right? Now some of the students might have worked with absolute functions for the details. So for them, let me write down a couple of more questions here. Now you need to figure out whether these are continuous or not, right? So we'll just change this function to x minus 2 over x minus 2, right? And is this function continuous or not at x equals to 2? We could also have a piecewise function. For example, we could define a function f of x, which could be, let us say, x minus 2 for x greater than 2 or greater than equal to 2, right? And it could be equal to, let us say, 2 minus x when x is less than 2, right? So let this be the function, and if this is the function, you need to answer whether this function is continuous at 2 or not, right? So that could be a good question. So think about these two and answer. Well, while you think, here is your solution. If I have this absolute function divided by this function, then the graph which I expect to get is kind of, let us say this is 2, right? This is 2. So at 2, it is not defined. If I put 2 in here, you get 0 in the denominator. You get the point. So the function is kind of like this, and it is like this. So where the values are plus and minus 1. So this value is plus 1 and this value is minus 1. So there is a jump discontinuity in this particular case. So that is why that particular function is not continuous. Here, if I substitute 2, then what is f of 2? F of 2 is, this is equal, so it is 2 minus 2, which is 0. And what is f of 2 minus? Let us say minus means when we are approaching from the other side, right? So close, so it is equals to 2 minus 2, which is also 0. And since these two values are 0, this function is continuous, and that is very important for you to figure out. Okay, so this function is indeed continuous at x equals to 2. As an exercise, what you can do is you can sketch this function, right? So that could be an exercise. So try to sketch this function, which could be, so at 2, what happens really, that is a straight line which will be kind of minus 2 is the y-intercept straight line going with 2. So from here to straight like this. As far as the lower half is concerned, so if I write x equals to 0, you get 2, right? So, but if I write x equals to 0, you get 2. And in this particular case, if I write x equals to 2, I get 0. So that is wrong. So it really starts from here, right? So this is the line. So let me correct it. Okay, so this is wrong for us. If I write x equals to 2, I get 0. So the slope is increasing. So that is the line. And this 2 point is included here, right? However, if I write x equals to 2 and plug it in here, what do I get? I get 0, right? So for the second half, it will be a hole here, since and this hole is matched with the plugged in point. And if I write x equals to 0, I get 2. So that is 2. So it could be kind of like this. You see that. So that is the function which we are talking about. And this function is kind of a function like that. Do you see that? So that is how we could actually get this function. That is a continuous function. I hope with this exercise you understand how to find functions which are continuous or not continuous at a given point. So that is the beauty of this exercise, and I hope that helps. Thank you.